All right, so again, protons tell you what element it is, and now we got to find the charge for the element. If you guys remember from the previous class, charge is equal to the protons minus the electrons. So we have 35 protons minus 36 electrons. That's going to give us -1. So the charge for bromine will be -1. So we just write the minus sign. Okay, and there you go. That's how you write the symbol for this ion right here. The protons gives you Br, the element, and then 35 protons minus 36 electrons gives you the charge, which is -1. And we just write a minus sign for -1. Okay, very similar for number 2. We're going to look at the atom that has 26 protons. So we just go to the periodic table and we look for the guy that has 26. So we just scroll a little to the left, and you'll see that 26 is going to be iron, Fe. So 26 tells us that it is Fe. And then we just do protons minus electrons. 6 minus 3 is +3. So we put Fe 3+. Okay, just a reminder, make sure for these ion symbols, you put the number before you put the positive and negative sign. All right. All right, any questions on that? Hopefully not too bad. Today will be very similar. We'll be talking a lot about ions. We're going to start putting these ions together, but should be pretty simple. All right, so today's lecture, if you guys notice, is called Most Common Ions. Now, if you guys want to write down MCI, this is how I abbreviate most common ions. So if you ever see this, the 3 letters MCI, just know I'm talking about this right here. And most common ions is exactly what it sounds like. So every single one of the elements, or not every single one, but a lot of the elements, they have an ion that they want to become, that they're most commonly found in. So that's what we're going to be talking about today, the ions that these elements want to become. So it's very easy to identify it. I want you guys to take out your periodic table because we are going to be writing on it. We're going to put some more information on it. But when we take out our periodic table, I'm going to show you guys the pattern to figure out these elements, MCIs. All right. So very simple. Some of your periodic tables might actually have these on the top already, but every element in this column right here, the first column, these guys all want to become +1. So if you want to write that down, you can. Some of your periodic tables might already have these, depending on which copy you got. But this column, everybody wants to become +1. Definitely write down the red part. You guys don't need to write the blue part. This is just going to be for you guys to understand. So hydrogen right here wants to be +1. Li, lithium, wants to be +1. The next one, Na, wants to be +1. You kind of get the point, right? Every element in this column right here wants to become +1. All right. Next column is going to be the second one and kind of follows a pattern. These guys all want to be +2. Okay, so Be wants to become 2+, Mg wants to become 2+, Ca wants to be 2+, so on and so forth. Okay. And again, you guys don't need to copy down the examples. As long as you get the pattern down, should be good. All right, remember that section in the middle we talked about last time, the part that we skipped? These guys don't have a pattern, so I'm never going to ask you to find the MCI for like iron or Cu or things like that. So these we can ignore. We're going to skip to the other side of the tall section. Everybody in this column wants to become +3. Okay, so you guys can see the pattern. 1, 2, 3. All right, this is where we kind of have a shift. So everybody in this column wants to become 4, but they want to become -4. Okay. All right, next column, we're going to go back down. So it's going to be -3, and then -2, -1, and then this last column right here, these guys have no MCI. Okay, these guys do not want to become ions. Okay, so make sure you guys have this on your periodic tables, the ones that you guys use for the assignments and quizzes. It'll be very helpful as we go on to the new information. But everybody in this column wants to be +1, +2, 3, so on and so forth. All right, so let's talk about what these MCI things mean. Okay, so these charges actually give you some information about whether or not the element wants to gain or lose electrons. So let's take a look at this positive 1 right here. So every one in this column wants to become positive 1. What that means is the elements in this column, they want to lose 1 electron. Okay. And the reason why is because electrons are negative, right? So if you get rid of something negative, you become more positive. It's like how if you have a negative friend in your life, you get rid of them, you'll become a little more positive, right? Just like this class. This class is a negative influence in your life. Once you guys finish and pass and you get rid of me, you guys will be a lot more positive, a lot happier. Okay, same thing with electrons. Okay, and then the same pattern. Everybody in this column wants to be +2. What that means is they want to lose 2 electrons. And then same thing for +3, they want to lose 3 electrons. Okay, so that's why they form these most common ions. It's how many electrons they want to get rid of. All right, the negatives are the exact opposite. So positive means you get rid of electrons. Negatives mean they gain electrons. So everybody in this column, because they want to become -4, that means they want to gain 4 electrons, right? They get more electrons, more negative people in your life will make you negative. Same thing here. They become more negative because they're getting electrons, which are negative. And the same thing for -3, -2, and -1. All right, any questions on the most common ion, the pattern, what it means, whether they want to gain or lose electrons? Hopefully not too bad. All right, so let's take this information now and we're going to apply it to the new thing for today. Okay. All right, so I want you guys to write down this part right here. Okay, cations and anions are attracted to one another. Okay, so you guys have probably heard that term, opposites attract, and that's pretty much true in chemistry. So cations are positively charged, anions are negatively charged. And what happens is, if a cation and anion see each other, they'll be like, oh, that ion looks kind of cute. And then they'll get closer and closer together, and then they will get super duper close, and then they'll get married, they'll combine, and they form something called an ionic compound. So just write down this part right here, and then this term, ionic compound. So again, cations, which are positive, anions, which are negative, they are attracted to one another. And what happens is when you put them next to each other, they combine, and they form something called an ionic compound. Okay? You don't need to write the full definition. Okay, it's just what happens when you combine a cation and anion. Okay, and today what we're going to be doing is we're going to be learning how to figure out what kind of ionic compound you make, depending on what cation and what anion you have. Wow. Alrighty, guys. So we're gonna jump straight into a practice problem, and it's pretty simple. We only have 4 practice problems, and today's questions are pretty easy. So if you guys have any questions, please ask me, just because it's gonna be a short lecture anyway. So for number 1, okay, we're looking at these 2 ions. So we have K, potassium, and we have F, which is fluorine. Now, before we answer the question what compound they want to form, I want you guys to go to your periodic table and I want you to write down what's going to be the charge. What's their MCIs? What ion does K want to become? And what ion does F want to become? So go to your periodic table, find K and find F, and then look at the pattern we just learned about and write down on your paper, on your note paper, what ion does K and what ion does F want to become. Okay, I'll give you guys like 30 seconds to do that. Shouldn't take too long. What ion does K and F want to become? All right, guys, so let's take a look at our periodic tables. If you look at K, K is on the first column of the periodic table, right? It's on the first column. So K wants to become +1. So on your paper somewhere, make sure you have K plus. All right, F is on the other side of the periodic table. And if you guys notice, F wants to become -1. And so the answer to the first part of this question, the MCIs, K wants to become +1, so K plus, and F wants to become F minus. Any questions on finding the MCIs? Hopefully not too bad. All right, so what's going to happen is, again, opposites attract. The cation and the anion, they're going to think the other one is really, really cute. So they're going to get really close to each other. And what's going to happen is if you combine them, they form the molecule KF. Okay, that's it. Super simple. So again, the positives and the negatives, they get close together and they make their compound. Okay, so that's really easy. Let's do one that's a little bit more difficult, but I think it's still pretty easy. On your papers, I want you guys to write down the MCIs for Na and O. Okay, so for number 2, I want you guys to go to your periodic table, find Na and O, and I want you guys to write down their MCIs. All right, so hopefully you guys found O on the right side. O wants to become 2 minus, and then Na wants to become +1. Okay, so O wants to be 2 minus, and Na wants to be +1. I'm recording. Just let it go. All right, any questions on the most common ion part? Hopefully not too bad. All right, now, if you guys take a look at number 2, this one's a little bit different, right? Because number 1, if you guys notice, the charges are +1 and -1. So they balance each out perfectly, okay? However, if you look at this, the 2 ions, this one is +1 and this is -2. So even if you put them together, what's going to happen is they're not going to balance out. The oxygen has more negative energy than the sodium does. So they have to balance each other out. So in order to balance out oxygen's -2, what we need to do is we need to add sodium until it can counteract the -2. So since sodium is +1, we're going to need 2 of them in order to balance out the -2 from the oxygen. Okay, so what you're trying to do is you're trying to balance the positive and the negative energy, and that's how you can get the correct ionic compound. Okay, so if we put these guys together, 2 NAs and an oxygen, the molecule that you're going to form is Na2, because there's 2 of them, and then O. So that's going to be your answer. The ionic compound that you form is Na2O. God bless you. All right, so the key here is you want to add the cations and the anions until they balance out in positive and negative energy. All right, one thing I do want to mention, though, is that when you write down these ionic compounds right here, I want you guys to make a note. There's going to be no positive or negative charge when you put it together. Okay, make sure you guys write this down on your notes somewhere, because I always get people writing plus and minus on the final product. They put like plus here, minus here. You can't do that, because once they combine, the positive and negative energy, they're balanced out, so they don't exist anymore. Positives and negatives are balanced. So don't put positive and negative on the final answer when you combine the cation and the anion, okay? All right, any questions? We're just going to do 2 more practice problems, and then I'll get you guys started on your assignment. Okay, this is super easy. All right, so I want you guys to work with the person next to you. You're going to use your periodic tables again, obviously, but I want you guys to take a look at number 3 and number 4, okay? I want you guys to figure out what ions these guys want to form, okay? Give you guys about 3-4 minutes to try that out. Check with the person next to you if you finish a little early, and then we'll go over them, and then we'll get you guys started on your assignment, okay? So try 3 and 4. Okay, if we take a look at number 3, we got Al or aluminum and chlorine. So Al is 3 plus. If you guys look on the periodic table, we look at the periodic table. Al is right here, so it's positive 3, and then Cl is negative 1. So make sure you guys got those two for the ions. Okay, now if you guys notice, we're putting these together and there's way more positive energy this time. And so in order to balance out the aluminum, you're going to need 3 chlorines. So if you put these together, you're going to make the compound Al, and since you only need one of them, just leave it by itself, and then 3 chlorine, so it'd be AlCl3. Okay, so your answer should look pretty much exactly like that. Okay, you need 1 aluminum, and you need 3 chlorine, so you write Al, no number behind it because it's just 1, and then 3 chlorine, so you put a 3 behind it. Okay. I also do want to mention that typically when we write this in chemistry, we always put the positive, the cation first, and then we put the anion second. Okay, so if you did Cl3Al, you're technically right, but it's just not the way that we write it. And I think on your Canvas quiz, it will mark it off. So just make sure you guys put the positive one before the negative. Okay. All right, let's go to number 4. And this is about as hard as it's going to get for these problems. So if you guys were able to get number 4, then the assignment's going to be pretty easy for you guys. Okay. So for this one, it asks you to find phosphorus's MCI. So if you look for phosphorus on the periodic table, you'll find it right here. And you'll see that it is -3. Okay, so phosphorus's MCI is -3. So P3 minus. And then it gives you the charge here. So Ti is on the middle of the periodic table, but it gives you the charge. So we're just going to write Ti 2 plus. All right, so for here, you're going to notice that you have more negative energy. So let's try to counteract that with some positive energy. So we're going to add Ti 2 plus. But if we do that, now we have way too much positive energy, right? Because we have positive 4. Yes. Yeah, go with the one that's given to you. Yeah, Ti doesn't have an MCI, so I'm not going to ask Ti's MCI. Yeah, good question. So Ti is positive 4 now, so we got to balance it out with some more negative energy. So we add another P3 minus. But if you guys notice, now we have more negative energy. So last step, we got to add another Ti 2 plus, and that's going to give you a balanced charge. So this is now going to be positive 6, and this one right here is -6, and so they balance out. And so basically what we need is we need 3 Ti's, so we're going to write Ti3. We need 2 phosphoruses, so P2. And that's your final answer. And again, this is about as hard as it's going to get. If you guys were able to get this or you understand it now, then you should be in pretty good shape for today's assignment.